Okay, so here we have a question. Without using long division or synthetic division, prove that x squared plus 5x plus 6 is a factor of x to the power of 4 plus 5x to the power of 3 plus 2x to the power of 2 minus 20x minus 24. So already from the question, we can tell that this is our divisor and this is our dividend. So first we're going to start off by factoring our divisor first, okay? So our divisor is f at x equals x squared plus 5x plus 6. Okay, so now we need a sum of 5 and we need a product of 6. And those two numbers are going to be 3 and 2. So we can sub that into our equation now. Now what we're going to do is we're going to group these together, the first two terms together and the last two terms together, and we're going to factor those. So a common term between x squared plus 3x is x. So we're going to factor out x. A common term from 2x plus 3 is 2, so we're going to factor out the 2. Now we're left with the same two binomials, which is x plus 3. Now we're going to group the x and 2 together, so now we're left with x plus 3 and x plus 2. So these two are the factors of this equation. Now if we were to look over here, it says that in order for p at x to be a factor of f at x, when the zeros or factors of f at x are substituted into p at x, the remainder should be 0. To determine this, we're going to set x minus b equal to 0, and we're going to solve for the x value. And so that's done over here. So we have x plus b, or x plus 3 is equal to 0. Now we're going to bring the 3 on over to the other side, which becomes negative. And so as you can see, it turns negative over here. Same thing. So we're going to do x plus 2 equals 0. Bring 2 on over to the other side, so it becomes negative. So x is equal to negative 2. Just keep in mind that it should be, or the p at x should be equal to 0, the remainder should be 0, if these numbers are substituted in. So that means that this will be a factor of this. So let's try that on the next page. So as you can see over here, I just made a little note of what we did before. So we did x plus 3 equals 0, x equals negative 3, x plus 2 equals 0, x equals negative 2. So now we're going to sub these two numbers into our equation over here. So let's try negative 3 first. So we're going to do negative 3 to the power of 4 plus 5 times negative 3 to the power of 3 plus 2 times negative 3 to the power of 2 minus 20 times negative 3 minus 24. We got 81 minus 135 plus 18 plus 60 minus 24. And look at that, we get 0. So that means x plus 3 is a factor of p at x. Okay, now let's try negative 2. So negative 2 to the power of 4 plus 5 times negative 2 to the power of 3 plus 2 times negative 2 to the power of 2 minus 20 times negative 2 minus 24. We get 60 minus 40 plus 8 plus 40 minus 24. And we also get 0. So that means these two are a factor of this equation right here. Okay, so that means that this equation is a factor of this equation. And I know it said not to use any long division or synthetic division, but just to check, we can check doing our long division. So again, this is our divisor, this is our dividend. Once we do our long division calculation, we can see that our remainder is 0. So since our remainder is 0, x squared plus 5x plus 6 is a factor. Moving on to our final statement, so therefore x squared plus 5x is a factor of x to the power of 4 plus 5x to the power of 3 plus 2x to the power of 2 minus 20x minus 24, as the sum of the function when negative 2 and negative 3 are plugged in are 0, as you can see right here.